Hey guys, welcome back. In this video, we are going to keep working with variables. In the last video, which I will link below, we learned about strings, but Python has a lot of data types that can be stored in variables. We're going to focus on numbers and Booleans. Let's take a look at our goals. By the end of this video, you are going to be able to differentiate between string, Boolean, integer, and float data types. You're going to be able to perform simple arithmetic following BEDMAS principles. And finally, you're going to be able to learn and use Boolean operators to do comparisons between data types. Now, variables are great because they can hold many different data types. Our phones and laptops do a lot of computation with numbers, and these numbers are just one type of data that we can store in variables. In this video, you're going to learn about the two main types of numerical data in Python, and at the end, should be able to perform simple computations with them. Let's get into it. So you should already have this notebook downloaded and ready to go so that you'll be able to code along with us. And then when you're ready to run the code, just hit Shift Enter and you should be getting the same results as we do. Now, as I mentioned, in Python there are two main types of numerical data, integers and floats. Integers are whole numbers, so some examples are 8 or -9 or 0. And we can assign these integers to variables. Here are some examples. We have score computer at 1 and score for Herco camp at 3. When we use our print function on these variables, the screen will print out the numbers we assign to them. Let's go ahead and try that out. Don't forget to hit Shift Enter to run. Cool. We see that the results are 1 and 3, which matches up exactly with what we declared in the previous cell. So floats have decimals in them, and they're followed by one or more numbers after the decimal point. Keep in mind that the number after the decimal point can still be a 0. Here are some examples of floats. We have pi, b, and notice that at b there's a decimal and a 0, and we have c. What if we assign a variable and later on forget? What if we're not sure about the type of number we assign to a variable? We can use the type function in Python. So similar to the print and input functions, we type the function and pass in an input. Don't forget the round brackets. Let's check whether some of the variables we defined earlier are integers or floats. Cool, so that gives us an integer. Let's check another variable. The value of what we wrote was a float, even though it was a number 12. So keep in mind that the decimal is very important. Now, one of the cool things about coding is that we can do math with integers and floats on the computer. Your calculator is actually a small computer that performs the same operations. Let's go through some math operations that we can do. We can start off with addition. Now, one really interesting thing about all these math functions is that if you use a float in any of them, you're going to get a float back. Let's see what I mean over here. So as you can see, the first addition had only integers, and so an integer was returned. But the other two have at least one float in them, and so it defaults to printing out a float. It's the same case with subtraction, but let's test it out. Great, so we see that it follows the same behavior as the addition. So for multiplication, we use the star symbol. Again, we're going to try and combine integers and floats in our operations to see what happens. Great, so that should be the exact behavior we were expecting. Now, division is a little tricky. So with floating point division, by default, the division operator will always return a float. This is usually a good idea so that you keep precision in your computations. Let's try it out. So notice that even though we had both integers in the top one, we still got a float. Now, Python is really cool because we can also do a second type of division using the double / operator. This operator is special because it will return an integer if both numbers are integers. It does this by rounding down to the nearest whole number. Let's try it out. Cool. So 10 over 5 is 2, but then 3 over 2 should return 1.5. But we see that it rounds down to 1 because we use the double / operator. So exponentiation is another function or operator that we can use. And this one uses the double star, so similar to multiplication. Awesome. Now, we can also do more complicated operations, like this one. I'm going to go ahead and set two variables first, just so that it's easier to highlight the operators that we're going to use. Notice the order of operations that was performed. So instead of going from left to right, the computer did the operations in the following order. So first it did y times 2, and then it did x plus that result, and then it took that result and divided by 7. This is actually the same way we perform order of operations in algebra or BEDMAS. Now that we have all these arithmetic and variable tools under our belt, let's try and play with a bigger example. These are the temperature values for the next week from Weather Network. Why don't we compute the mean or the average temperature for next week and print out the result? Go ahead and pause the video to try this out. Here's a hint. The average is the sum of all numbers divided by the number of numbers. Welcome back. This is one way you could have solved it. So I decided to put the result of summing all the variables into one variable called total. So I went ahead and did that, and now I'm just going to take my variable total and I'm going to divide it by 5. We'll hit Shift Enter and we'll see that the answer should be 23.2. Now, sometimes we have a numerical variable that we want to increase. One example is if you wanted a counter variable to keep track of every time you take a step. There are two ways we can do this. We can reassign the value of a variable to say that it equals itself plus something new. Let's take a look and see what that looks like. So we're going to declare our variable count. We're going to set it to 0. And then what we're going to do is we're going to say count is equal. Actually, first I'm going to check and make sure that the value of count is 0 before we do anything. And then what we're going to do is we're going to write count is equal to count plus 1. Now let's go ahead and print the value of count and see what we get. I may have given away the answer there. So awesome, you see that before when we printed count, the value was equal to 0, and then we added 1, and the value is now equal to 1. We can also use the shortcut way with something called the plus equals operator. Method 1 and method 2 are equivalent. It just depends on your style and which one you prefer to read. So we're going to go ahead and do the same thing. We're going to set our count variable equal to 0, print it out to make sure it's really 0. Then we're going to write count, oops, made a typo, count plus equals 1. And so this is the exact same as saying count equals count plus 1. Let's print it out. Awesome. So it also gives us 1 after we use that. Now, sometimes we want to do other types of operations with our number variables. For example, what if we wanted to find out if one number was larger than the other? Or what if we wanted to test whether two variables contain the same value? When we do these types of comparisons, the output is always either true or false. These kinds of comparisons have a special name in programming. We call them Boolean operators. Here are some of the Boolean comparison operators. We have equal to, not equal to, greater than or equal to, less than, and finally less than or equal to. Why don't we try to use these in an example? Let's pretend someone is playing a game against a computer and we want to compare scores. So first what we want to do is create our score variable. So I'm going to make one for the computer, set it to 1, and one for the player, and also set it to 1. Now, let's check. Does the player score equal the computer score? So this output's true because computer score and player score are both 1. The cool thing about Boolean comparisons is that we are not limited to seeing if two numbers are equal. We can also see if two strings are equal. So I'm going to go ahead and declare two variables again. I'm going to call them player move, and I'm going to set a string called scissors. And I'll do the same thing for the computer. Okay, let's check again. Is the player move equal to the computer move? So this actually outputs false. And this is because scissors and scissors aren't the same thing. There's actually a capital in the second word, and that counts. Let's try the not equal operator. So again, I'm going to go ahead and set a player and computer move. And now let's check whether they are not equal. So it's taking a little bit of time to run on my computer. Cool, so it outputs true. That makes sense because rock and scissors are not the same thing. Now, let's say we play another round and the player wins. What if we wanted to check if the player score is now greater than the computer score? Well, we can set, again, two variables and use our Boolean comparison operator to check. So I'm going to give the player a score of 2. And now let's check using the greater than operator. Good, so it outputs true. Now, let's say the computer wins another round and we want to see if the player score is greater or equal to the computer score. So here I'm just making note that I've increased the computer score by 1 using the shortcut operator we learned about earlier. And then we're going to use the greater than or equal to operator to check. Perfect, so this outputs true, which is what we were expecting. And now we know that computer score has to be at least as large as player score, if not greater. You can use all Boolean comparisons in similar ways by comparing variables containing floats, integers, and strings. Why don't we try one final example? Let's say my goal every week is to run 10 kilometers. If I pass my goal by Friday, I can buy myself an ice cream on Saturday. Did I achieve my goal this week? Why don't we use Python, arithmetic, and Boolean comparison to check? Pause this video now and see if you can come up with the answer. So, did I reach my goal? Let's check. So I'm going to take the same strategy I took before. I'm going to create a variable called total, and then I'm going to add all the weekday variables together. Then I'm going to go ahead and check whether the total is greater than 10. So the answer should be true. I did run more than 10 kilometers, and now I get ice cream. Awesome, so that is it for numbers and Booleans in Python. Let's quickly recap everything you learned. You learned about integers, floats, and Booleans. You learned how to do arithmetic using math operators, and you learned how to do comparisons using Boolean operators. Using Boolean operators can be tricky, so be sure to rewatch the video and ask us questions in the classroom if anything is unclear. See you in the next video.